Hi everybody, I am Kyle Cordes at Oasis Digital. It is April 2017 and I am going to attempt to persuade you today that there are many common cases in your old AngularJS applications where you really need to use RxJS or equivalent to get correct results. So I hate About Me slides, so no slide, just a quick look at my website. I mentioned I'm at Oasis Digital. Again, no slide. You can look at the URL there if you're interested. And thirdly, I teach at Angular Bootcamp, and you can take a look at the URL there if you are interested. Okay, so I mentioned AngularJS. So it is April 2017. Why am I even talking about AngularJS? Well, the reason is that a very small slice of our work here at Oasis Digital, even in 2017, is still on AngularJS. We have a couple of small internal apps still on it, and more importantly, we still keep meeting customers who have mission-critical apps on AngularJS. So we still spend a small slice, admittedly, of our brain power thinking about it. And in the process of that, we ran into these scenarios and found that things we were doing in Angular 2 could be backported to Angular 1 and quickly, easily, and efficiently solve problems in Angular 1. Okay, so let's take a quick look at my demo app. I have two different versions of this demo app. They both look exactly the same, so I'll just bring them up and look at them. Let's get this out of the way for a moment. So the way this app works is you can just type some letters and you're doing a search. And the search is actually a full text search of the information about a person. So if I start to type part of their name, that works. But sometimes I can type some letters and they'll maybe be in the middle of the name. And then sometimes I can click and you'll occasionally see that de.view. I could actually find that text also because it's finding text anywhere. So I have it's labeled name filter, but I ended up expanding it to search any of the data. And then secondly, you can also control the sort order. So that's it. No big deal. You can do some basic filtering and you can do some sorting and you can click to see details. So this is equivalent to numerous, just very numerous real screens that we've all seen in many applications many times. So let's take a quick look at the code for this. The code for this is very vanilla, ordinary AngularJS code. So we have an index page. It loads Angular. We use Lodash for that sorting you saw. Then we have a module file. This employee loader has a service implementation in it, and then this promise delay mechanism, and we'll talk about that in a moment. Then we have a component for this chunk, and then we have a component for the overall list that then uses that chunk. So I think I'll just quickly walk through those details of that code. So again, we have this app module. All this does is declare the existence of a module, so there's really nothing to even look at there. Employee loader. Now this is a service. You can see down here it says service. In fact, here, let me make this just a little bit bigger. So this is a service. Now I've chosen to write this service using an ES 2015 class, which you, by the way, are allowed to do. So even though this is AngularJS 1.6, I believe, I'm still going ahead and using class. It's 2017. It's okay to type classes now. I'm not compiling this, so I don't have a build process on this tiny example, but we certainly do this for real applications, and we use a little bit of a simple build process to make sure we can run on legacy browsers that don't natively understand a class. But it turns out a lot of browsers today understand the class and don't even need a compilation step. So again, this is just an ordinary AngularJS service, but instead of giving it a service class constructor function, we actually give it a service class. So as you can see, injection works kind of as you might expect. You might not have seen this before if you've never used classes in Angular 1. This service class exposes two services, a way to get a list, a way to get the details. These are very vanilla ways of coding in Angular 1. So we have an HTTP GET with some parameters. Looks like our backend accepts these parameters. In terms of how this backend works, the details really don't matter, but if you're curious, you can go look up this off-the-shelf thing called JSON server. It's really slick, makes it really easy to get a really basic server for development and demos up and running with no coding. So I didn't have to do any coding to be able to bring you this server-side search functionality. That is important, though, that this is using server-side search, so it is coded like a real enterprise application would be. We don't just load the entire employee list into the browser. The list is presumed to be larger than we would want to bring into the browser. Now, the only thing really unusual about this code is lines 24 and 30, and these are a mechanism. You can study the mechanism in this other file if you're interested. It doesn't really matter. The important thing is that it adds a certain amount of latency and then a certain amount of additional random latency, we call jitter, to each request. So in development, it's sort of safe to assume your services always respond almost instantly. Real services tend not to. So we're going to look at the code a little bit, then we're going to crank these numbers up. Okay, so that's all the kind of code other than the component. So again, very little code. Here's the code for the component. So we have a template. This template is just a template for the overall screen. There's nothing super exciting here, except you might not have seen this used. ng-change, it has been there quite a while, but prior to Angular 1.5, you would typically use ng-model and then do a scope watch. Well, scope watch, I don't know if it's officially deprecated, but it's definitely strongly discouraged now. So instead of doing a scope watch, we just ng-model for our filter, and then we just use an ng-change to trigger some action to happen when the user changes the filter. We do the same thing for the sort, so a model and a change, very routine. And then some answers come back, which we handle with a repeat. Then we do just a little bit of styling so that if we have a specific person selected, we get this nice yellow bar. And then lastly, we have delegated the display of the details to this other component. And that's nice because it's going to let us reuse that other component. Now, that other component has essentially the least possible code for the component, just a single incoming binding, and then a view template that shows various fields of that binding. So there's nothing interesting or unusual there either. Okay, so the last piece of code that's relevant for our promise-based implementation is this. Now, this is the controller for the component that basically runs the whole screen. You might not have seen this syntax before if you've been using Angular 1 for a while. The syntax is that we have a component, but the controller, instead of being a function, a class constructor function, the controller is actually a class. And again, this is legitimate. This just runs directly in the browser on all of the modern browsers. And if you want to support older browsers, it's a very simple compilation step to get that. So I can do a constructor with injection. I'm just injecting that employee loader that I showed a moment ago. And then in the constructor, we typically set up all the fields that are going to be used. And then we have a few other methods, and these methods are made available on the controller, I guess on the scope, so that in here, for example, this is the template for the overall screen. Whenever someone changes the name filter, it's going to run this function in there in the controller, name filter changed, and so on. So let's just walk through what happens here. So I'm going to pretend I'm a user typing. So as I type keys, we get this name filter change called. Each time that's called, we go to that employee loader and we call the get list. Well, the employee loader get list, that's just very vanilla AngularJS 1 code. It does an HTTP get, it grabs the data field out of the result, and then it adds this random delay, which we'll use to illustrate an important idea in a moment. If the sort changes, we don't even requery the data. We just resort the data in place. And I brought in Lodash so I wouldn't have to code my own sort, because I'm not trying to show how to do sort here. I'm trying to get to a different, more important point. Lastly, if I click on a specific employee, again, we use the employee loader to make a different endpoint call. And when that data comes back, we shove it into the component so that it will be passed into the detail view component and displayed on the screen. So I've now walked through everything that happens as I click around here. Now, let's make this interesting. Let's say that instead of having a fast, reliable service that takes 100 milliseconds plus an additional up to 100 milliseconds to answer, let's say that I'm simulating what happens when someone actually deploys a real service under load in production. You might see something like a 150 millisecond baseline or something, where the fastest request might take 150 milliseconds, and that's still very, you can make a very fluid app with that. But let's say that things are real bad and the users sometimes run over a VPN, over a hotel Wi-Fi or something, and they actually have a really high jitter. Some of the requests just take longer to come back, and there's nothing you can do about it. So now we've just simulated a slightly ugly network condition, but not an unusual network condition at all for what real big enterprise applications have to live in. So I'm just going to refresh the page, and now watch what happens. I will click on somebody, and there's a delay before their information appears. I click again, there's a delay. These delays are different each time. So let's see what happens. Let's say I'm a developer very carefully developing and testing, or let's say I'm a human tester, and I'm trying to validate this screen. So I'll click, and then I'll stare longingly at the screen for a moment and verify the fields seem correct. And then I'll click, and again I'll stare very carefully at the screen. Oh yes, this application is working perfectly. With each click I do, I verify that the right thing happens, so this thing passes all of its tests. Fantastic, right? Well, let's say on this network that has variable response time, let's say a user goes click, 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 a little bit faster. Well, what happened there? Look, I have a person selected here and a different name up here. And if I click real fast, I can very frequently have that happen. So if I click through 4 people there, I'm kind of anybody's best guess. Sometimes I end up with the final one I clicked on, sometimes I don't. So what's happening here is that each request for data because of one of these clicks is happening separately and asynchronously, and there is absolutely no guarantee that the results arrive in the same order as the user clicked on the buttons. So since I have this, again, incredibly straightforward, common, vanilla, everyone codes this way code, because of this very straightforward code that seems quite correct, I now have a visibly buggy program in the presence of any kind of variable network latency. This kind of stinks. This is not great. On the other hand, I would say that 80% of the real Angular 1 applications that I see actually have this kind of misfeature or latent defect hiding there in the presence of variable network latency. How do we fix it? Well, of course, the most obvious way to fix it is just pretend it doesn't happen and set these numbers back down to small numbers, or just define correctness of the application as, well, of course the application only really works correctly if your network is fast. If your network isn't fast, leave me alone, go talk to your network people. So I guess that's one way to solve it. That doesn't really seem like a great way to solve it to me. So let's look at a different way to solve it. Okay, so from everything we've seen so far is what's in the Angular 1 box. Let's reach slightly outside the Angular 1 box, and let's reach for RxJS. Now, many people who are still using Angular 1 for some of their applications are nonetheless already familiar with RxJS because they're using it in their Angular 2 work, or their Angular 4 work, I guess I should say now. So there's a good chance that at least some of the developers on any substantial Angular 1 project already know just a little bit at least about RxJS. So my argument is that it's not scary at all to add this line to my file and make RxJS available inside my Angular 1 application. So let's take a look and see how that works out. Okay, so this file, these two files side by side. This is the old one we just studied, and it's 39 lines long. Here's a new file. It achieves all the same things and then some. It uses RxJS, and it's actually 6 lines shorter. So don't be afraid that adding RxJS to Angular 1 is going to make programs larger. It's typically going to make them smaller. First, I'm going to give a quick overall example of how this works, and then I'll come back and I'll kind of talk through it line by line. So let's go ahead and look at the the RxJS version. So I'm going to load this other file. Now, with RxJS, the most important thing to know is that we're using observable streams to wire up the different parts of this screen. And observable streams know how to keep themselves in order. It's in the box. As a developer, you don't have to do anything to tell an observable stream to stay in sequential order. It just always does that. And so with this, everything unchanged, I can click, and no matter what my latency, I always end up with consistent results. So I can click through here, and at the end, even if I was clicking back and forth and I had lots of variable latency, the one I end up with is going to be the one that lands over here once all is said and done. So the important thing here is that the RxJS implementation is correct in the face of variable network latency, and the straightforward, everybody does it, Angular 1 promise-based implementation is incorrect in the face of variable latency. Now, given that incorrectness, in theory, that should be sufficient motivation to start using it. But it can be scary, so I'm going to try to look through the code and try to explain how it works and maybe try to make it just a little bit less scary. Okay, one critical piece of magic to be aware of is that I am depending on this thing called the Angular 1 Async Filter, which adds something to Angular 1 that works and looks very much like the async pipe in Angular 2. With this, I can take asynchronous data, such as data from RxJS, and I can directly consume that in an Angular 1 template. HTML template. Curiously, it actually works for promises also, although the reason I'm using it is because I want to use RxJS Observable. So it's important to remember I'm using this third-party aftermarket thing called the Angular 1 Async Filter, and you can go search for this thing on the internet and so on. It's mentioned in the README for my repo that I'll share in a few minutes. But that's the only piece I'm using that's sort of not in the box. I'm using Angular, which comes from Angular, Lodash, everybody's very familiar with, Materialize to make it look pretty, RxJS, which Angular 2 relies on, so there is every reason to trust it, even though Angular 1 does not require it. The only really oddball thing I'm using is this. This thing is about 2 screenfuls of code, so it's really not too much to be afraid of. Okay, so first I want to compare the templates. So this is the template that I was using with promises. And so I would take an ng model, and then I would ng change, and in my change I would call this filter changed. Well, I do something just a little bit different here on line 12. I actually have to do just a couple more words here, because I'm going to take this new name filter value and I'm going to push it into this observable stream for reasons we'll see when we look at the code. And then likewise over on the promise-based implementation template, down on line 18, again, I was just calling a function when the sort changed. So when we look on line 18 here, I'm doing that same little, just a tiny bit more syntax, where instead of calling a function, I'm taking the new value and pushing it into an observable stream. And then lastly, down here, we just repeated over this controller filtered list. Well, with the asynchronous observable-based implementation, we have to do just very slightly more work. So again, it's the same number of lines, but if you look at line 26 on both, we have to do the slightly odd syntax. And this is just a bit of an odd syntax to work around some limitations in how Angular 1 works. But as long as you're willing to type the pipe character and async :this, you get very close to the same functionality as we're used to in the Angular 2 async pipe. So the template then is really essentially unchanged, just a couple of minor syntactic differences, which means the only real meaningful difference between my promise-based implementation of this simple app and my RxJS-based implementation is just the difference between this JavaScript file and this JavaScript file. Now, I already talked my way through this one a few minutes ago, so I think this means the only code I have yet to explain is this guy. So let's take a look. So same pattern. We go to our Angular module, we define a component, we tell it where the template is, and for the controller, again, I'm giving it a class, because that's okay now, because I just like using the class syntax. It's 2017. You certainly would be welcome to use the the constructor function pattern that you see in the Angular documentation instead. Okay, so there's a convention, I'm not sure how wide this convention is, but there's a convention at least somewhat used where when you have a variable that has an observable, you put a $ on the end. I'm not sure if I like it, but it's really great when you're teaching somebody how this stuff works, so I went ahead and used that naming convention here. So I have a name filter, a sort, and I have some identifier of who's selected, and then I have my filtered list, and those are all observable data. You can tell because I've named them with the $. If we were working in Angular 2, I'd be using TypeScript, and I'd be making these a type that shows they're observable, but there's none of that. This is not Angular 2. This is just Angular 1. This is just JavaScript. There are no types, so I have this naming hint to help me remember that these are observables. The way you access RxJS features, if you're just sticking the script on the page, as we are, is when you need those features, there's this predefined variable Rx, where you get the features. So an RxJS behavior subject is an observable that you can push data into, and that always has a value. So the name is not great, but that's what it means. So in this case, we're saying that the initial value of this thing is whatever is in here, which of course is right there. And then this name filter $, when the user changes the name that they've typed on the screen, this is the syntax to stick this new value into that observable. So with that one line of code and this one line of code, we now have an observable stream of the user's search criteria. We do the same thing for the sort. So again, with one line of code in the template, one line of code in the template right here, and then one line of code in the component controller class right here, we now have an observable stream of the user's sort selected. Then with one more line of code, we have an observable stream of who is currently selected, of their ID. So these are all trivial observable streams. And now we get to the interesting observable stream. So the filtered list, the way we get the filtered list, now we're going to get deep into RxJS. So whenever I get deep into RxJS, I point out, go read this documentation. If you just search for RxJS, you're likely to land on the documentation for RxJS version 4, and that's very unhelpful because many things' names have changed between version 4 and version 5. But if you go to this URL that I have shown right here, you will get the documentation for RxJS version 5, which is what I am using here. Okay, so combine latest is a way of saying take one observable stream, take another observable stream, and whenever either one of them produces a new value, run a function to combine the results together and give me an observable of that. So it combines this observable stream with this observable stream, and then it combines them using this function. So the second observable stream that it's combining, this is easy to understand. This is just the sort stream that we defined a moment ago. And then here's the function that combines them. Well, it just combines them by using the low-sort by. So this is just exactly the same code as we used before to combine some data with a sort. So there's really no innovation here. All of the innovation is right here. So this one here, this is tricky to explain, so I'll try to do them carefully. So name filter, this is an observable stream of that filter criteria, the search criteria the user typed. So every time the user types anything different, another value will arrive and be pushed into this chain of observables. The only thing we're doing that is a thing called switch map. Switch map it should be your best friend. Switch map is the best way in the world, well, at least it's the best way with our current tool set we're talking about here, to direct loading data from the server based on some change from the user, because switch map does all the right things. So switch map wired into an observable stream, it preserves order. So this behavior that I wanted, that I said was so important here, of when I click around, I always get the final answer as the one that appears. Switch map preserves that property. It'd be slightly, I guess I can't tell you here because I'm simulating the latency on the client side, but it's pretty important. If there was real server latency, this is capable of implementing cancellation of requests once they become obsolete, which is otherwise very tedious to implement. It automatically rewires the outer observable to the results of some new observable generated by calling this function. So I need an observable to be generated by calling a function. So I take this filter, this will just be like a string, you know, an or whatever, and then I call the same get list we just saw, but I need this to be an observable, not a promise. And this is just leftover code, and it uses the Angular 1 HTTP, and that returns a promise. So there's just this little line of code just to shim it and say, well, this promises are great, but I need an observable. So this makes that promise into an observable. Then switch map wires it up to the changing name, and then combine latest says whenever you have new data from the server, take the sort order and then rerun the sort. So basically this chunk of code, it's a little hard to understand if you've never seen it before, but it replaces a bunch of this code with, well, it kind of replaces some of that code too. So it kind of replaces a few more lines of code with a few less lines of code, but more importantly, it replaces code that's demonstrably incorrect with code that behaves correctly in the presence of variable latency. So I would argue that even if it was twice as long, you still should use it because it's more correct, but in fact it's more correct and it's shorter. Okay, one last piece. Over here, again, in the promise-based code, whenever someone clicked, we called GetDetails, we got the promise, and we took the answers and they came back, and we stuffed them on the component so they could display. And this, totally vulnerable to that out-of-ordering problem. That same idea implemented here is not vulnerable because, again, it's taking a observable stream of who's selected, and then it's a switch mapping, which preserves the order. It's calling GetDetails, which gives a promise, and then it's turning that promise into an observable. It's taking the results, it's making that selected employee observable available in the component. And if we just want to take a look at what happens with that one, I searched, I got a little bit too much. So let's just get that bit. Let's find out where he's used. So he is only used in one place, and here we go. So we took that thing with the $signs. That means it's an observable, so you can't use it directly. We ran it through that Angular 1 Async Filter to get a value, and we passed it to the exact same detail view component that I was already using. So just to reiterate, the only difference between these two implementations is this file versus this file. And if you've been writing things like this, if your code base is full of this, I would heartily recommend spending some time studying this instead. Okay, so I think I've gotten through everything I wanted to explain here. I've showed the incorrect behavior that you can very easily get with kind of a naive promise implementation. I've showed that you get correct behavior with fewer lines of code using an RxJS implementation. I've showed that your templates will either be, in the case of a kind of view-only component, is exactly the same, but even where you're using these features, your template is a relatively modest change, a modest update, not a big deal. And I've talked through both the promised and RxJS-based ways of actually implementing the heart of the functionality. So I think that means I'm done. I wanted to wrap up by pointing out, if you want to study all this code, it's really tough to read in a video where I'm just flipping through it, but here is the URL for the repository where I've published it. And I haven't done it yet, but I'm going to put a link to the video in the repository also. But you can get in here, you can check this out, you can npm install it, you can npm start it and run it. You can play with all this locally just by cloning this repo and then running a couple of commands. It's got a README that'll get you started. So for everyone that made it this far, let's see, we're 29 minutes in. If you made it this far, I really appreciate your attention, and good luck for your continued AngularJS work, and I hope you use RxJS. Bye-bye.